So we'll continue our discussion of SAT practice test number 8, section 4. Calculator questions here in problem number 19. We'll kick off this video, and this question says that the range of a polynomial. So we're going to have to remember what's meant by the range of a polynomial here in just a second. Range of a polynomial is the set of real numbers less than or equal to 4. Okay, less than or equal to 4. Well, if you remember what range is, range of a polynomial, range of a function, would be the y values represented by that function. We need the range to be less than or equal to 4. So if you look at option C, we've got y values on this graph here and again over here where they're above 4. So option C is out, same for option D. Option D goes up above 4 on this little stretch here. So options C and D are out because they do not have the range that we're supposed to have. Options A and B are okay. It looks like they get up to 4 for the high y value, but they never exceed 4. It goes on to say the zeros of f are -3 and 1. Which of the following could be the graph of f? Well, if you remember what's meant by the zeros of a polynomial, those are simply the x-intercepts, or where y is equal to 0. This graph has a 0 at, looks like -3, and at 1. Seems like option A is going to be the answer. If you look at option B, it's got its zeros at -1 and at +3. So if you accidentally mixed up which one got the negative attached to it, you might accidentally pick option B, but we're definitely looking at option A for our answer. Number 20 is talking about energy consumption, and they tell us that the average annual consumption is $4,334. Homeowners are going to spend $25,000 to install a geothermal heating system. They're going to estimate that then the average annual energy cost is going to reduce to $27.12. Which of the following inequalities can be solved to find T, the number of years after installation at which the total amount of energy cost savings will exceed the installation cost? So let's think about savings. I look at the right side of these first two options. If I took the current cost, which is $43.34, and subtract the projected new cost, the answer to that difference would give me the savings per year. And if I multiply that by T years, that'll give me the total amount of savings across T years. Well, I'm going to want to know when the total amount of savings is going to be above the cost of installing the system. If you look at option A, $25,000 is greater than the expression we've looked at for the last few seconds that involves savings. But look at option B, $25,000 is less than the amount of savings. And that would mean that the amount of savings has now exceeded the cost of installation, and we are going to have a conclusion of option B. Next couple of questions go together. So we've got, let me shrink this a little bit here. So we've got a scatter plot, and they tell us between 1985, 2003, we've got data collected every 3 years on the amount of plastic produced in the United States measured in billions of pounds. So they've got the scatter plot. They tell us that the equation of the line of best fit that's shown in the scatter plot is this. X is the number of years since 1985. Y is the amount of plastic produced annually in billions of pounds. Number 21 asks us to determine the best interpretation of the number 3.39 within the context of the problem. Now, if you look at where the number 3.39 sits within the equation, 3.39 is multiplying x. 3.39 is the slope of the line of best fit. If you've talked about slope in applications in the past, you've probably called slope a rate of change. So let's check out some of these options. I'm just going to kind of glance down through them. Rates of change are units of one thing per unit of something else. So I'm just going to scan my units. Billions of pounds in A doesn't really seem like the right option. Number of years it took doesn't really seem correct. Average annual plastic production in billions of pounds. I mean, it is average, so it would be billions of pounds per year, so possibly option C. Option D, the average annual increase in billions of pounds of plastic produced per year. So here's that per year, which kind of makes it tempting to go with option D. It seems like we can safely rule out A and B. Those are not going to have the right sort of units that we would need to see for a slope calculation. They're not units that would be indicative of a rate of change. So let's think about this. Option C, the average annual plastic production in billions of pounds from 1985 to 2003. Well, here's 1985 at time 0. Here's 1983 at time 18. The average annual plastic production is way above 3.39, right? We're up at already 50 billion pounds just at the beginning of that time frame, and we are way above it, over 100 billion pounds, over double that amount at the end of the time frame. So the average annual plastic production definitely seems like it's going to be well above 3.39. Why is it option D? The average annual increase. So as we do a rise and a run, a rise and a run, a rise and a run, we're going up by about 3.39 billion pounds per year across the extent of this line. And that's why option D is going to be the correct option here. If you look at the next part of this problem, it's based on the same information. We're just asked to do something a little more involved with it. Which of the following is closest to the percent increase in billions of pounds of plastic produced in the United States from the year 2000 to the year 2003? So what I wanted to do is I wanted to use the equation of this line of best fit right here to figure out about how much plastic was produced in these 2 years, 2000 and 2003. Now I had to realize that I'm not going to be putting those numbers, 2000 and 2003, in place of this X. X is being measured in years since 1985. So that means the year 2000 is actually 15 years since 1985. 2003 is 18 years since 1985. So I used this equation. I did this calculation with the calculator since it's in play here. The prediction for 2000 is 97.74 billion pounds of plastic, and then for 2003 at the X value of 18, we get a little bit above that. I wanted to know what the amount of increase was. So the amount of increase, if I take the higher value minus the lower value, I get 10.7 billion pound increase between 2000 and 2003. If I want to know the percentage increase, might be hanging off the bottom of what I'm able to show you here. Try this, I guess. So if you think about how you're going to determine the percentage increase, what you're going to have to do is you're going to have to take the amount of increase, which we've already determined, 10.71 billion pounds, and you're going to have to divide by the starting amount. The starting amount was the amount in 2000, so the amount at X equals 15, which was 97.74. Now, if you do that division on the calculator, what you get is you get 10.104. Now, we're looking at options that are all percentages here. So you realize that that's the decimal or the rate that represents the percentage. To turn that into the actual percentage, we have to multiply it by 100. Move the decimal over 2 spots is what that amounts to, which gives us 10.4%. And there's really only one option that's close to that.